Hi, I'm Alan Ross, and we are at DTECH 2025. We've got interviews with thought leaders, and we'd love for you to see what we've done here. Hey, thanks for joining us. My guest is Seth Johnson. Seth is you're the president and
general manager of our corrections business division, yes.
Okay. President and general manager. You don't hear that very often. You usually have the president and the general manager works for the president, working his butt off for the president. Right? Talk a little bit about how you got in the industry, Seth. I know you and our readers know you, and we've done interviews before, but somebody has not heard you or read you yet. In the February issue?
Yes. Well, great to be here, Alan. Thank you for having me with you. So I actually got into the industry in somewhat of a unique way. I didn't have an aspiration to be in the power industry or in power systems or engineering related, with power systems technology or anything like that. However, I was in research early on in my career. So I worked in biomedical research,
and that's how you got into power.
Well, it's kind of interesting if you think about it. I ended up buying a piece of equipment for this research that I was doing, and it was actually a variable frequency drive.
Okay.
Yeah. So you've heard of a variable frequency drive, right? You use it, takes power, and it adjusts the speed, of the motor by augmenting the output. And the company that I was working with has said, you kind of got to knack for this, would you ever be interested in getting into the power industry? And at the time I was like, probably not.
Honest answer.
Yeah, very, very honest answer. But then I had a family member that was actually in the power industry, and they had reached out to me at the same time. So I was like, well, maybe this is a sign. Okay. So I made a career change, was going to be a neuroscientist was my plan initially. And then moved over and worked in sales for an electrical manufacturer's rep, selling all different types of products, including variable frequency drives. And that's what ultimately got me into the industry. And then I found quite a passion for it as I continued to learn more about it. And it's just a fantastic industry. I mean, look at what we have here at DTECH. I mean, it's unbelievable. So that's how I ended up getting into it. Then I got involved in Powerside early on in probably 2012, 2013, and then became a permanent employee in about 2017.
Okay. And that's, 8 years ago now. We're going to talk about Powerside at the end, but I want to talk about something that I honestly believe that 10 years ago, if you'd have been looking at the industry, you'd have said, it's a boring industry. But what has excited a lot of new people coming into it is the amount of change that's going on in the industry, primarily at the utility side. I mean, there's more change going on, I think, arguably, in the last 5 to 10 years than there was in the 50 years, maybe even 100 years before that. Being at Powerside, being kind of a student of whatever you do, what do you think the changes that they're going through now, and where has it brought us to when you look at your client base, the utility industry?
Yeah. Well, you bring up a great point, Alan. I mean, if you think back to, early power distribution, right? The battle of the currents between Thomas Edison and George Westinghouse, right? I mean, that's, let's get lighting to people's houses, right? And, then the above ground power feed came into play. It originally started as direct current, migrated to alternating current.
I think it was Pearl Street in New York was the first.
You got it. Yeah. So, and I'm not quite that old, but
well, neither am I. I just okay.
But you look at the power system infrastructure, and one of the things that I think that's really great about where we're at today compared to the last 50 years, and what's really driven a lot of the change, is the diversity of load profiles from a your standpoint. Okay. So you have a very different load profile now, specifically over let's say, the last 20 to 30 years compared to, 50 years prior. And a good way to think about this is, loads back, 50 years ago primarily were linear loads, okay? They drew power sinusoidally, okay? They didn't cause a lot of problem, okay? And again, I kind of want to reference the battle of the currents between, George Westinghouse or Nikola Tesla and Thomas Edison, because what we've transitioned to is more energy efficient models, okay? And a lot of that requires converting AC to DC, right? And sometimes converting AC to DC and back to AC again. And so the way that we have looked at these technologies, which again have become much more efficient, they've actually caused a lot more, I don't want to say problems, but challenges on power distribution, right? So there's a lot of benefits to it. And then, of course, now you still have a fairly aging infrastructure in a lot of these, utility power distribution lines. And what you're seeing is with load demand growth, they're having a hard time being able to maintain the infrastructure on the utility side. So there's a lot of different standards that are coming out for interconnection requirements, right? You can think of standards for, harmonics, right? From a consumer, that would be like an IEEE standard 519. Or if you're a renewables DER site, IEEE standard 1547. Right. And so they have different standards that they have to meet. But if you rewind 5-10 years, those standards are always constantly evolving. And the grid's not necessarily keeping up with all of that, right? And the whole intent of these standards is that the grid can then absorb everything else that is, that's being produced. But, everything's kind of lagging, if that makes sense.
Oh, that's a great, I have not heard that before, is the load profile. We hear about load, we just hear about load. Oh, increasing load. I know that I was speaking with a lady from Southern Company, and she said they expected a 1.2% load growth a decade ago. They're at 8% load growth now. Now, fortunately, they just opened a nuclear facility in West Georgia. It's already basically sold out. That's just meeting some of the load growth of AI distribution data centers in North Atlanta. So the idea that these organizations that are so used to pretty much steady kind of load profile, low growth, are suddenly responding to both. And the utility industry is not one that necessarily responds to both. I think they're responding incredibly well, given the fact that there's so much complexity that's how. Interconnectivity, you mentioned that. Talk a little bit about, because I think that's a big problem today, is people, hey, buy my thing, buy my thing, buy my thing. But my thing doesn't talk to your thing, doesn't talk to our thing. Interconnectivity is a big issue. Talk a little bit about that.
Yeah, so, everybody wants data, right? But we've gotten to this point where there's like data indigestion. Really, it's like, well, how much data do you want? And what are you going to do with it? And what does it mean? And so, of course, I play more in the power quality realm, right? So I'm looking at data in more of a power quality fashion, but, everything from substation control, out to grid edge, and then all of the devices that now have communications capability, but what platforms are available to allow you to pull data, that's needed for all of these devices, right? And I see that as a big challenge, Here at DTECH, you're looking at, several companies that have got great software platforms and all different types of, data analytics capabilities and, smart transformers and all different kinds of great things. And I think all of that is the future of where we're going. But I always like to say with the utility, unless they're willing to invest at a massive scale in in some form of a platform to be able to utilize and look at that data, it won't be used. Right. And the reason why I say that is because you see a lot of, requirements for, devices like, let's say, a recloser. I want it to have all of these options. I want it to do everything. But they're only using it to do a few things, maybe, right? And so now you have a lot of different devices out on the, on the power distribution system that can do a lot of things, but we're not utilizing all of their capabilities because there's really no platform necessarily there for all of it. And, are you going to sit there, look through Excel spreadsheets and CSV files to do everything? And so for us, and one of the things I see the industry going to is, dedicated platforms for specific assets, particularly with transformers, right? I mean, you saw what happened at London Heathrow, I think it was Heathrow Airport, right? No, that could have potentially been avoided, with the right type of software platform to look at the health transformer, so on and so forth. So I think there's a lot there, but again, the utility, especially at the distribution level, has to have a need to have that data. And until they find the need for that data, that's where the limit of the investment, I feel like, is.
One of the things, you just brought it up, Powerside works in the power quality area. We see a growing issue with distributed energy creating more harmonics, more transients, leading to more power quality issues that the people have, that companies are having. And now the utilities got to deal with it. Whereas it was push out to everybody else and just, that's whatever now they're taking power from everywhere and sending it out to you. Microgrids create their own set of problems. They don't solve all the problems. People say, I got a microgrid. I don't depend upon it anymore. But when you do, you have to have an interconnectivity to it. Talk a little bit about power quality as a whole, because it's a good future for Powerside.
Yeah, absolutely. So, with distributed energy generation, distributed energy resources, we've seen a lot of power quality related issues on power distribution lines.
And why is that?
A lot of it has to do with the fact that you're using, let's say, generally speaking, wind or solar,
right.
And you're taking DC power, converting it into AC, right? And again, you're relying on an inverter-based resource or an inverter to do that. An inverter is using a power electronics device to do that, as opposed to the old massive rotating inertia generator, right, which you didn't have essentially a harmonics-related problem. But one of the things that is interesting, and Alan, you were kind enough to let me write about this in your February issue of Power System Technology, is that the power distribution infrastructure is severely underdampened, okay? And what I mean by that is that because a lot of it is aging quite a bit, and you have very old assets on there, let's say old capacitors, I got a long lengths of underground cables with high capacitance in them, etc. What you get is what's called resonant frequency issues, okay? And so when you have power generation, which is essentially nonlinear, and you have basically the source of your power, the strength of your power changing. Sometimes it's coming from a nuclear facility over here. Sometimes it's coming from solar over here or wind over here. The strength of that power is changing. And what happens on the distribution line is that the levels of harmonics can drastically increase or decrease at any given time. And I like to think of it in a way of speed limit, right? We're all very familiar with driving on a freeway. We've got a speed limit of, let's say, 80 miles an hour.
Which means 89.
Right. Well, maybe to you. I mean, I go 90, but...
I heard that if you stay if you do 89, you're not going to get a ticket. Go ahead.
So 80 mile per hour speed limit, right? Well, I'm going to give you an analogy of, in my mind, how I think the grid is today, okay? You're driving at 80 miles per hour down that freeway, but then it turns to a dirt road for a short period of time, okay? And you're still going 80 miles an hour, okay? You might blow a tire. You might spin out. You might, something might happen. You might blow a suspension, right? But then it turns back again to that nice highway, right? And that's essentially what's happening at times on these distribution systems. Okay? And you see this a lot with heavy renewable integration, okay? So I like to think the speed limits are the standards that are put in place that like IEEE sets or, various other governance groups set. But the problem is that freeway, that nice paved asphalt, it turns to a dirt road for a little while, and then it turns back to that asphalt, right? And you're not changing your speed, and you need to change your speed, because that's when you get kind of catastrophes that occur. So that's kind of a weird analogy, but
no, I like it. I love that. Yeah, because typically what will happen when you go through the window, because you're going to come to a pretty abrupt stop. Let's look ahead. I want to, what the problems are today. We know what the challenges are that we're all trying to address, and the utility industry is addressing them pretty well.
Yeah.
What do you think the next 5 to 10 look like in terms of problems? Is it just a continuation of what we've got, or are we going to look at something different?
I think, it's a very old industry, right? Now, and so seeing the receptivity to change over the last 5 years really has been incredible, specifically for the power industry. And a lot of it's needed, I do think you're going to see a lot more cogeneration. And I do see that, there is a push for some of these DC microgrids. Because, Alan, if you think about it, we're converting AC to DC, and then at some point you're like, well, why not just have DC here? Right. We're charging our vehicles with DC. We're running our VFDs with DC. Let's just have DC here for now, So I do believe that there will be a play there longer term. But I think as we look over the next 5 years, the technology that's going to come out for, assets that are currently used on power distribution systems are going to evolve. And with that, I mean, some of the evolution we see in the tach changers market, because that's one of the biggest challenges we're seeing is voltage stability issues. Okay. Even maybe paring that down at the voltage regulation level with voltage regulators and, other types of general assets. But, the AC power distribution is still going to be the backbone of the power distribution. But I think the other side of it is the standards are going to get more and more, I don't want to say strict, but they're going to be more and more well-informed with the data that we're gathering, from companies, for instance, like Powerside and other companies that are, either the power quality or power reliability space, which really ultimately drives these standards, and that's going to really future-proof the grid long-term because, we kind of have an idea of where it's going.
Okay. You mentioned it a couple of times, but I want to be a little bit more specific. Given all of those challenges, all of those changes and opportunities, because that's really what this industry is undergoing, is the biggest opportunity, a group of opportunity, a collective, right? Because we create problems when we solve problems. And we seem to be solving a lot of problems and creating a lot of other problems. Talk about Powerside particularly. Where are you all going in terms of this? I know what your pedigree is. Yeah. Power quality is your pedigree. What are you working on, or is it just more of the same, but a lot more of the same?
Yeah. Well, in a way, it's more of the same, but we're focusing a lot on data analytics. Okay. And so, we're capturing with our high fidelity power quality analyzing devices, we're capturing instances that occur on power distribution systems and pairing them with actual events so we know what's going on, okay? And we can categorize those events so that utilities can know what's happening. For instance, let's say there's an inverter failure somewhere from a solar or a generation facility or DER connection point. We may have a load profile of what that looks like and a signature for that, which then, could alert them. But I think the other part of it is I told you about the kind of the power distribution line being a highway, right? And then turning to a dirt road. And one of my goals as a leader at Powerside is to try to make sure that dirt road doesn't happen. Okay. And so what we're working on right now is a series of studies specific to looking at how we can use filtering technology to dampen an entire power distribution system. So the whole idea would be, we're able to allow for all the distributed energy resources connected, all of our nonlinear loads connected from a consumer standpoint. But then the utility doesn't have to worry so much about whether or not they can handle the type of loads and the load profile and the type of power generation that occurs with that, with those specific industries.
When you say you're doing that, one of the things that I see utilities more open to than they have been in the past is other people making decisions for them. Yeah. That's to this extent, that's got to happen when you're going to say, hey, this is a decision. You should do this based on our knowledge. Is that a fair statement?
Absolutely fair.
And 10 years ago, that was not going to happen.
No. Well, you realize, Alan, with some of these problems, utilities don't necessarily have, let's say maybe a power quality group, right? That have, that really just focus on that, And so we become, in a lot of cases, almost an engineering arm for them, right? Or at least a resource for them. And that even also goes, at the industrial level as well, because these utilities also care about their consumers who are connecting to them.
Exactly.
And so a lot of times they'll come to us and say, hey, we've got a customer who's creating these problems. Please provide your expertise, And that is something that we've seen a huge, drastic shift from, 10 years ago just to today.
I would also think there's got to be, I could think of a situation where a power quality issue was shutting down a series of freezers. There were a place that they made chicken, put it in a thing, and then they fast froze it or flash froze it. Well, these freezers, they brought in the new generation of robotics control. They didn't have to manually do anything. The fans turned on. It was brilliant, but they kept going offline as they were, and it would be millions of dollars of lost chicken parts, right? They couldn't figure it out. Lo and behold, one of the engineers, floor engineer, he said, well, where is that feed coming from? There were guys from the freezer company. There were local people from the utility. Somebody was getting bad power, and it was tripping something, and then they all went offline. It was a power quality issue coming in from a primary sub that was getting the power in from the utility, so the primary substation was owned by the company. They were taking that dirty power and passing it into a robotic system, and it couldn't handle it.
Yeah.
They've been doing it the same way for years, never had a problem.
Right.
They fixed that, put in a little controller transformer, $1,500, solved the problem. So power quality at the industrial side, data centers hate it. You want it nice, clean. So that's good for power side.
Yeah, absolutely.
Yeah.
Yeah. When, we see a lot of applications like that, and even, you bring up data centers. I mean, data centers, obviously with AI, load growth, massive amount of load growth. But, some people forget that a lot of that is in just the cooling that's required for that, right? And so, we're doing a study right now for a company that that's all we're trying to do is sell the power quality, and it's all related to the cooling for a large data center.
Yeah. Excellent. Seth, as always, brilliant. I appreciate it very much. Thanks for being with us.
Thank you, Alan. I appreciate it. And thanks for having me on the show and be a part of Power Systems Technology. Appreciate it.